All right, be sure you've logged your attendance and submitted that. Your quiz will be at the end of the slides today, so be sure you get the quiz solved and submitted as well. Today we're looking at section 3.5, and 3.5 deals with graphs of rational functions. Now, rational, just as a very quick reminder, rational means we are dealing with fractions. So all of these will be in fraction form. And we're looking at two things about the graph. We're looking at the vertical and the horizontal asymptotes. Now, asymptote is a pretty fancy math word. Simply put, all it means, it is the undefined values on the graph. All right, so we did some of this before. Back in section 2.2, we looked at finding the domain of a rational function. And if you recall, we said the domain comes from the denominator. So that's one of the things we're going to use in order to determine the some of these asymptotes. Okay. All right, you have a graph in your notes. Looks like this. And I gave you the function down here. Now, we're going to look at how to find the asymptotes from this function. We're not going to be using graphs at all. You're not going to be graphing these in WebAssign. You're only going to be given the function and asked to list what the asymptotes are. So you can see here, we could have a vertical asymptote. That's this red dotted line that goes up and down. Or we could have a horizontal asymptote. And that's the red dotted line that goes from left to right. Both of these, as you might notice, are listed as equations. X equals 2 over here, y equals 1 over here. So when you list your asymptotes, they need to be equations. Be sure you remember that. And there's a reminder of that in the notes as well that we'll highlight. Okay, so let's look at how we find these. We're going to start with vertical. So if a real number is a 0 of the denominator, remember a 0 is any number that makes that value equal 0 when we plug it in, then x equals c, or x equal to that value, is a vertical asymptote. Okay, so with vertical asymptotes, there can be more than one. And again, it must be an equation. Be sure to highlight that in your notes and maybe even put a star next to it. You have to write it as an equation. That equation is going to be x equals some number, whatever that number is. Okay, so we have three examples. We're going to look at three different types here. So the first one, again, we're only looking at the denominator. So we're going to take this denominator, x squared minus 5x minus 6, and we're going to see what values make it equal 0. Those are the values that are going to be our asymptotes. So for this one, we can factor. So we get x minus 6 times x plus 1. Be sure your factors agree. Be sure your signs in your factors agree. And from those two factors, we get x equals positive 6 and x equals negative 1. So those are the two values that make the denominator 0. Those are the two values that represent our vertical asymptotes. So there you go. Okay, letter B, we're going to do the same thing. Looking at the denominator, we're going to say that x squared minus 64 is equal to 0. For this one, since we just have x squared, we can get that by itself by adding 64 and then take the square root. So x squared is equal to positive 64. When we take the square root on both sides, we're left with x equals 8 or x equals negative 8. Those would be our two vertical asymptotes. So remember, if you take the square root, remember you're going to get two solutions. Okay, our last one also same thing. We just have an x squared in our denominator, so we can solve this by using square roots. So if this equals 0, we would subtract 2 from both sides. And you may already see what the problem is going to be with this one. Let me slide the screen over a little bit. So we get x squared equals negative 2. Well, this is on a graph. So in the last section, we said we could use I because we were just finding the zeros. But now we're looking at the asymptotes, and we have to be able to graph this. So x would equal I times radical 2 or negative I times radical 2. Those are not real numbers. And that means we cannot graph them. Let's label that here, not real. So because of that, that means for this equation, there are no vertical asymptotes. So it is possible that you have no asymptotes at all. Again, we have to get real solutions. So if you have a situation like this and you don't get real numbers, then these would not be asymptotes. We would say that there are no asymptotes. All right, the second one is a horizontal asymptote. So a different process here. For horizontal, we have to look at the degree of the numerator and denominator. Now remember, degree is just a fancy math word for the highest exponent. Now, highest exponent should be the first exponent, but sometimes the numerator or denominator are not written in standard form. So be sure you check that and look to make sure you're using the highest exponent. So we're going to compare those, and you can see there are three rules here when the numerator is less than the denominator, when they are equal, or when the numerator is greater. So remember, anytime there's an x, that exponent is 1. So here, the numerator exponent is 1. The denominator exponent or degree is 2. So that means the numerator is less than the denominator. That's our first situation up here. If that happens, then our horizontal asymptote is y equals 0. So as long as our numerator degree is less than the denominator, our asymptote is going to be y equals 0. Okay, for our second one, our numerator degree is 2. Our denominator degree is also 2. So this time the numerator is equal to the denominator. And you can see that's the second situation. Let's slide up a little bit. And in this case, the asymptote is the quotient of the leading coefficients. So our leading coefficient for the numerator is 2. The leading coefficient for the denominator is 3. So our asymptote would be y equals 2/3. So that's when the degrees of both of them are equal. Now, the last one is when there is no asymptote. So if the numerator degree is greater than the denominator, then there will not be one. So you can see in our last example here, our numerator is 3. Our denominator is 2. So the numerator is greater than the denominator. So there is no horizontal asymptote. Now with horizontal, another thing that's a little bit different. So just a quick reminder, we always write them as equations. It's y equals this time. And with horizontal, there is only one possible. So if one does exist, there will only be one. Vertical, there can be more than one, but with horizontal, you can only have one asymptote. Okay, that's really all there is for section 5. So given an equation, identify the vertical and horizontal asymptotes of the graph. All right, here is your quiz question for today. Be sure you solve this and send it in using the Remind app. Okay, so here's your quiz question for today. Be sure and work this out carefully, watch your signs, and send that in using the Remind app. And again, next class will be our review. So be sure you print out the review and bring it with you to class.